All right, good afternoon. I'm Tanya Greenwood, and this is Sarah Davis, and today we'll be presenting on the nesting preferences of black knotty terns based on the circumference, height, and horizontal zonation of nests in Pisonia grandis trees on Heron Island in the Great Barrier Reef, Australia.
Our study, like Tanya said, was on Heron Island. It's located off the eastern coast of Australia, and it's approximately 1 mile in circumference. It's encompassed by the southern tip of the Great Barrier Reef, and as you can see, half of the island is dedicated and reserved to a national park, whereas the other half has both a resort and a research station, which is where we stayed for 2 weeks this past January. It's a gorgeous island, and it has really suitable needs for snorkeling and scuba diving, but it was particularly useful in studying the nesting behaviors of the black knotty tern.
So speaking of terns, we'll give you a little bit of information about them. They are a seabird, and as such, they prefer coastal tropical habitats such as that found on Heron Island. Environmental factors and social factors influence the bird's preference of nesting on Heron Island, including the vegetation. So some studies have been conducted showing that these birds, about 73% of them, are found predominantly in Pisonia grandis trees. So vegetation affects where they nest. Wind speed and sunlight can also affect their nesting habits, as well as social factors such as competition between species. They also prey on fish found offshore of the island. They have a relationship with large tuna, which herd the fish to the surface of the water. So that also influences their choice to inhabit remote islands.
We were most interested in the relationship fostered by the Pisonia grandis and black knotties. The trees, as mentioned, they provide habitat to the birds, protecting them from heavy rains and intense sun commonly found in island ecologies. Interestingly, there is a steep trade-off for this type of protection. The Pisonia grandis produce a very sticky, barbed fruit, and the fruits often become ensnared in the feathers of the black knotties. It no longer permits them to fly or to attend their nests, and it consequently results in death. However, the decomposition of the birds underneath the canopy allows nutrients to recycle back into the system. And so as a result, the health of both the Pisonias and the knotty tern habitat are ensured in the future. So in approaching our research, we were curious to see whether the black knotties exhibited a preference within the Pisonias given the inherent dangers.
So since there's such a unique relationship, we are interested in how much research has been done on the nesting preferences of birds on Heron Island. Other islands, such as One Tree Island, also in the Great Barrier Reef, have had research done on black knotty terns and their nesting preferences in Pisonia trees, and they had found that indeed the birds appeared to prefer a certain size of tree for nesting in, and also exhibited distinct vertical and horizontal nesting preferences. So that kind of stirred our interest in the topic, and we explored to see if there is indeed relationships between the tree sizes and the nests found, to see if there is a distinct horizontal zone and where the birds nest, as well as if there are vertical zoning preferences.
So to kind of summarize that, we did predict that we would see a preference as the black knotties build their nests, and regarding the size of tree that they build it in. And similarly, we anticipate that the black knotties will nest within specific vertical ranges as well as horizontal ranges as they place their nests in Pisonia.
So to conduct our study, we did a line transect method in the North Beach, which is located in the National Park on Heron Island, using a table of random numbers and a coin toss to randomize our samples. We collected data on 49 Pisonia grandis trees and recorded for each tree the total number of nests, the height of the tree, as well as circumference. We took both of these measurements because there's a bit of discrepancy between the actual branching of the trees. They're kind of split out, so that's why we collected both measurements. We also recorded the height of the lowest and highest nests, as well as where the nests fell within each individual tree. We defined that as at the core, the interior and exterior of the tree. And a tangent height gauge was used to collect height information. To conduct our analysis, we used Sigma plot software, and we conducted a simple linear regression, a Mann-Whitney and t-test, as well as a chi-square test.
Of our nests that we recorded, 128 were located in the core of the tree, 73 in the interior, and then 102 nests in the exterior branches. A chi-square value was the 15.12, which indicates that there is a preference of black knotty tern populations and that they're not randomly distributed horizontally. And this table represents additional information. Of the 49 Pisonia grandis surveyed, 17 of them did not have nests, and 11 of them had 3 or more nests. And we chose these two sample sizes to compare just because of their sizes, just to keep it straightforward. The average number of nests per tree came to about 6, and the average height of the trees were about 10.9 meters, with the average circumference of 1.33 meters. It's also important to notice the vertical range in which the black Noddy terns nested. The average height, we averaged the height of the lowest and highest nests, and the approximate vertical range came between 3.9 and 5.5 meters. It's important to recognize that the brackets are the standard error.
All right, so this is a graph showing the relationship between Pisonia grandis circumference and the number of recorded nests. As you can see, there was a positive correlation and an R-squared value of 0.4. And we also showed a graph of the relationship between Pisonia grandis height and the number of recorded nests. There was also a positive relationship, and these values were statistically significant.
Next, we look at the relationship between which trees, those containing no nests and those containing 3 or more nests, and their relationship to their average circumference. As you can see, the trees with 0 nests had an average circumference of approximately 0.45 meters. The trees that had 3 or more were circumference averaged by approximately 1.44 meters. And this indicates that the black Noddy nests were significantly more abundant in the Pisonia grandis with larger circumferences. And next we made a similar comparison but with Pisonia grandis height, and the average height of trees with no nests was approximately 6.5 meters, and those with 3 or more nests was approximately 11 meters. So thus we observed that nests were found in greater abundance among taller Pisonias.
All right, so in discussion, we did observe many things. One, there did appear to be a vertical nest distribution pattern between 3.97 meters and 5.54 meters. Obviously, the birds probably avoid low nests because of contact with humans and other predators, and we hypothesized that they avoid the top outermost branches of the trees due to the dense fruit clusters that are found there. Also, the horizontal distribution of the nest was not random. This supports the study done by Cordova on One Tree Island. Indeed, the nests seem to be clustered towards the core of the tree. Again, this may be to avoid competitive interactions with other birds, to avoid the elements. The innermost part of the tree is protected the most, as well as, again, to avoid the sticky fruit clusters. As our graphs also showed for our linear regression test, there was a positive relationship between both the tree height and circumference and the total number of recorded nests. And this, in turn, essentially supports a size effect hypothesis, which is as the tree size increases, so does the number of nests. Until a size threshold is reached, that is, the tree is too large and there are no longer necessarily more nests. And this may be due, Barnes and Hill conducted a study on another island, also in the Great Barrier Reef, and they found that larger trees are actually disadvantageous to nest in because they're more likely to fall down in a cyclone, which we experienced on Heron. So they're not necessarily more ideal habitat. And also, the small trees aren't necessarily more ideal habitat because they're less sturdy.
So in conclusion,
I have one more, sorry. And lastly, the average height and median circumference between the trees without nests and those with 3 or more nests were statistically significant. So as I said, those medium-sized trees seem to provide the most ideal nesting habitat.
So just to conclude our findings, the birds avoid large and small trees and have a preference for the medium-sized trees. There is a horizontal distribution of black Noddy nests that is not random, and in fact there is a preference towards the core of the tree. And lastly, we concluded that individual tree size, both in height and circumference, influences the nesting preferences of the black Noddy. If we were to return to Heron to follow up on our research, we would be interested in further understanding how abiotic factors such as tree placement on the island would affect their nesting distribution. So our study was confined to the national park portion as well as trails that were more centrally located. But if we were to return, we would like to conduct an experiment that assigned coordinates to each tree, and it would observe whether it was found leeward or windward or centrally or externally on the island. And this would allow us to factor in wind or sunlight and see how these components might influence the nesting preferences. We would probably utilize GIS. Similarly, it's important to study nesting preferences of the black noddies for their survival. So climate change and expected fluctuations in the El Nino Southern Oscillation are expected to negatively impact the reproductive successes of seabirds. So in addition, there's tourism that's continually increasing among the Great Barrier Reef Islands, and understanding which trees are vital habitat when constructing new establishments and recreational activity things, it's crucial for their conservation efforts. Thus, additional research surrounding the nesting preferences of the black noddy tern can help to enhance the preservation of intact island ecosystems. Is there any questions?
Jim.
Trying to make believe I'm a bird making a choice. So from what I'm hearing, and forgive my ignorance, so the bird somehow, do they nest in the same place year after year, or is each year all bets are off and they start again?
Good question.
They tend to return to the same island, however, based on the fact that their guano is water soluble and the seaweed tends to fall off the trees, they have to continually rebuild nests. So it's like a process.
But then they go to the same spot in the same tree to rebuild.
Well, sometimes the trees are gone the next year based from windrow. So I don't believe they're coming back to the exact same nest, no.
But from what you said, at least the birds over time are sort of if I may, minimizing risk in choosing where they build their nests.
Mm-hmm.
But there's a lot of competition. I mean, there's a lot of birds inhabiting the island. So, I mean, our findings also showed that there was a lot of birds in the exterior of the branches, and we weren't exactly sure why that was. I kind of think it's like the best spots might be gone, so they need to nest still. So.
I've heard it twice now. I was wondering if you're overstating the dead birds providing nutrients for the trees. I mean, when you get there, can you see dead birds everywhere?
Yes.
Okay.
It's actually really
So you are
disturbing.
overstating it.
No, and it was most apparent after the cyclone came through. You would just find what's unfortunate too is you'd find the baby birds and they'd have the little stickies on them, and the parents will just say, oh, well, sorry, and they'll just recreate, they'll have a new egg and they'll restart because it's just a lost cause. But it's really sad because you want to get in there and pick them all out,
Sure you do.
but you just know it's part of the system and it all kind of comes back and ensures future habitat.
I mean, it ensures the survivability of both species.
Mhm.
Thank you.
Are the terns the only species that get caught up in the tree, or are there
No.
others?
There's two species of birds predominantly on the island, the black noddy tern and the shearwaters. They nest on the ground, like underground, and they also get stuck in the fruit clusters.
And we saw seagulls too.
And seagulls, yeah.
So it's kind of just a big trap, but we think it's mostly focused towards the black noddies because they are so specifically nested in those trees. So.
Do they have any other trees to choose from?
Yes. The answer is yes. There are other trees. Pisonia grandis by far was the most abundant tree on the island. So we thought, well, maybe this is just they don't have any other options, but there are other trees, but they seem to prefer the Pisonias, regardless of the sticky fruit clusters. I know you had a question back there.
Yeah, I was just wondering, have you observed when the birds approach the nest, they have to somehow move through the outer portion of the tree to get to their inner nest, right? So do they follow preferred paths, or do they just simply come in at all different angles to approach the nest?
Our research didn't really look into that. That's an interesting point. The trees themselves, they're not, I don't know how to describe them, but it's there's navigation room within the tree. The leaves are mostly focused on the outermost branches, so it's I'm not sure.
Well, even just through observation, when we're walking through the paths, the birds are at eye level. I mean, they're under the canopy kind of with us, and they're kind of dumb. They fly into each other, they fly into trees, they fly into us, and you have to duck out of their way. So they're very comfortable with getting lower under the canopy. So I can envision that being a tactic, is just to stay low and then ascend into their nest.
Is there any idea, maybe even what percentage of these black noddies don't survive because they're getting stuck into the...
Well, after the cyclone, about 50% of the population was killed, either through the trees falling or getting stuck in the fruit cluster, and all like the nests were devastated. I'm not sure of the actual percentage of the population. I would guess it's pretty significant, but they reproduce quickly, so I don't think it's necessarily adversely affecting them.
Thank you, ladies.
Thank you so much.